We are looking into position, distance, and displacement. First, let's consider position. In the concept of position, we reveal or show that it enables us to locate a point in space. And therefore, we look at the quadrilateral coordinate in this form, where we have this as the x, this is y, and this is z. Here we have this, and this itself is perpendicular to the x and perpendicular to the y. So we have something like a box, equilateral, quadrilateral box, okay, or something like a room. So any point in space, if this is P1, then we have the coordinate x, y, z. Coordinate 2, we have x2, y2, and z. So with that, just as we have it in the Cartesian coordinate, in a plane, we can equally locate position in space. Now, we can talk of the position relative to the origin. How far is it from the origin? The origin, of course, is the point at which the three axes intersect. If we are considering that, then we can be talking of distance. And so, what exactly do we mean by distance? And what do we use in measuring distance? Distance could be explained as this. If we have 2 points in space, the path, the length of path joining these 2 points, P1 and P2, gives us what we refer to as distance. It has no specific direction. Here we go round and meander until we get to what? To P. That's the only path connecting point P1 and point P2. And so the length of these is referred to as the distance. It is a scalar quantity. It is a scalar quantity, meaning it has only magnitude or size. It has no specified direction. So it is referred to as a scalar quantity. It is measured in meters. We have other smaller units, such as millimeter, the centimeters. We have the bigger unit, kilometers. We have more smaller units, micrometer, and so on, nanometer, picometer, you see, and so on and so forth. Now, looking at it, what are the instruments used for measuring distance. We can use just ordinary string to measure distance. Instrument used for measuring distance. For measuring distance. We can mention string. Why should we say string? If we know the length of the string we are using, assuming I've already measured it on a tape and get about 10 centimeters, and I come to the board and measure 10 of that, I know that 10 multiplied by 10, that's 100 centimeters, which will be a meter. So we can use string as long as we know the length of the string. So we can use tape also. Tape. Tape rule. We can use the meter rule. Meter rule. We can even use graduated cylinder to measure length. Graduated cylinder to measure length. Yes, if you want to calculate the change in volume of liquid poured in the cylinder, we can use the length. You see, graduated cylinder. We can use it. See, apart from that, we have other mechanical devices that could be used. Mechanical devices. This include vernier caliper. Vernier caliper. Not only that, we have micrometer screw gauge. Micrometer screw gauge. These instruments could be used even to measure the diameter of a very thin wire, electrical wire. We can use these. We can use these to measure the diameter of a bottle, both inner and outer one. Very small distance, these instruments are used for. So we should take notice of that. Now, having done with the measurement of distance, we can also look into concept of direction. The concept of direction. We know that we have what? The concept of direction. Concept of direction. In our mathematics, we might have learned bearings, and we might have heard of the cardinal direction, the north, the east, the south, and of course the west. In our bearings, we use 3-digit form, and if it is 3-digit form, the measurement commences from the north in cardinal direction. So the north in cardinal direction serves as 00 degrees and 360 degrees. So the angles are measured in the what? In the clockwise direction. So if we are talking of a point P located at the bearing 60 degrees, 060 degrees. That gives us the bearing. And what instrument do we use in measuring this direction, or to draw the direction? We can make good use of our pair of compasses, ruler and pencil. See, we can generate this. We use using pair of compasses, to draw bearing. We can see that bearing, what exactly is it is? Bearing is a specified direction. A specified direction. It specifies direction. See, if we talk of P, we can only locate P at 060 degrees, no any other place. If you don't go there, you can't locate it. So it is specified. So P is located at the bearing of 060 degrees. So bearing gives specified direction. We should note this. Okay. Now, let's look at what we refer to as displacement. A distance measured in a specified direction is no longer called distance. In the physics, we differentiate this. This is referred to as displacement. So displacement. Displacement. What exactly it is? By displacement, we mean distance covered. In a specified direction. In a specified direction. So assuming OP is 5 kilometers. See, the distance is 5 kilometers. But if I want to specify it as a displacement, I'll tell you that P is at a displacement of 5 kilometers, 060 degrees. I have to be specific. I have to specify its direction. The direction is 060 degrees. A physicist or a mathematician should know what this is. So it is quite different from distance. Distance covered in a specified direction. It is not a scalar quantity, but a vector. It is a vector quantity. Vector quantity. And what do I mean by vector quantity? By vector quantities, this is a quantity that has specified direction and, of course, magnitude. A vector quantity has both magnitude and specified direction. Specified direction. Magnitude and specified direction. Okay. It is also measured. It is also measured in meters, just like the distance. Okay. We have smaller units of centimeters, centimeter, millimeters, okay, micrometer, picometer, nanometer, etc., etc. And the bigger unit of what? Kilometers. So we should get this very clear. Okay. Now, so we have this, we've given the distinction between the what? Between the distance and the displacement. Why distance is a scalar quantity, displacement is a vector quantity. What is a vector quantity? That which has magnitude and specified direction. Whereas a scalar quantity has only magnitude. So we should get these very clear. Good. From there, we move into another topic. If this is very clear, we can be sure that in any problem that could be given related to this, we will be able to answer the question very, very well. I thank you so much for listening. Thank you very much.